Good morning, everybody. My name is Jason Fox. I'm the Senior Technical Evangelist at the FIWARE Foundation, and today's Wednesday webinar is about managing the short-term history within FIWARE systems. Today we're going to cover the following. What actually is short-term history and how is it relevant within smart applications? Which components are available to deal with short-term history? Short-term history is very much related with data persistence, slightly different, and therefore it can be covered as a separate topic. So find out which components we can do and how can we actually display a trend graph on screen. What options have you got there? And the fourth main area we'll cover, and we won't do this with a practical example, but it's the way of the future, is how can I use the NGSI-LD temporal interface to do similar operations? So let's all get started. If you want to follow on, all of my code is available within the FIWARE tutorials step by step. You can clone it as shown on screen. The prerequisites which are within the system, it's assumed you understand Docker, Docker Compose, Git, Postman, Cygwin if you're on Windows. I'm currently on a Mac, and I may also be using Compass. May not. I'm not sure. Not sure yet, but it depends on how we're doing our data persistence. Today we are very much dealing with the central core context management chapter of FIWARE. It's not the context broker itself. It's not the standard data persistence components. It's the other two elements, STH-Comet and Quantum Leap, which are to do with data persistence and reading of time series data, which is a slightly different subject. So we're not going to be going up into things like actually viewing this information using components like Knowledge or Wirecloud, but you should be aware that once you've actually got this time series data available, there are multiple ways you can read the data, multiple ways you can display the data and get information out on what is the context of your system over periods of time. So the first setup we're going to look at today is using STH-Comet. Now this is a relatively simple time series component which uses MongoDB for holding the data, but it actually does the aggregation of time series within the code of STH-Comet itself. Time series data is effectively moving your data persistence into buckets. You've got a bucket of what happened this minute, or a bucket of what happened this second, or other periods, months, weeks, days, whatever. So you can find out what has happened over a period of time. You might want to know what is the highest value over the last month. You might want to know what is the average, so you can smooth out differences within readings because your data may be somewhat unreliable. You might want to get hold of a sum or a sum squared for getting deviations. There are all sorts of operations which you can do, and we can see that thereafter. So Comet is a simple system here, which this is the setup for fast prototyping, where you've just got Comet, which is receiving subscriptions directly from the context broker. So let's see this in action. Bring that up. Whilst we're getting started, all we have here is a simple Docker image for persisting short-term history, and it's all a matter of just saying, okay, where am I listening on? I'm listening on standard port 8666, and where is my MongoDB database. The reason why Comet uses a MongoDB database is, as you can see from the diagram which I had previously, there already is a MongoDB database because Orion uses MongoDB at the moment. So you can keep it nice and simple. So we're now up and running. So let's see if we can get the thing going. Okay, so you can do a oops, don't need that. Don't need a cookie. Okay, you can do a heartbeat by just using the to the version. This is just to check that things running. If oops, done that again. Send, and it just comes back with the version of the component you're running, so we know we're up and running. In order to, as you would expect for any data persistent style of component, you need to listen in to changes of context within the context broker. Therefore, you must be using a subscription to do this. A simple subscription would just consist of give me an attribute, in this case count, for a type of device. If you look at my headers, you can see I'm also looking within my devices, my OpenIoT multi-tenant. So the strange thing about STH-Comet is that the interface it uses is still NGSI v1, and therefore you need to have this additional attributes format equals legacy in order to ensure that the data is passed through in a manner that Comet itself can deal with. If we send that, it just gives me a subscription created, as you'd expect. And similarly, if I want to do something like streaming data, same sort of thing. This is the lamp, but you can also add in throttling. This means that we are not overloading the component by putting lots of information. All I want from the lamp is actually to find out what the maximum and minima are. So I only want to I don't want to have a count of everything. Obviously, if I use throttling on the motion sensor, I would potentially be missing events. Whereas here, I just want to sample the lamp on a regular basis to find out what's going on. Right, let's go into the tutorial. We can do our usual trick of unlocking our door and turn the lamp on. Yeah, as you can see, I'm now streaming data into my database, into my context broker, which is then persisted into my database. And if I check my subscription, we are able to see that, yes, we are getting information through, and we are able to retrieve information. Having done that, you can then use the Cygnus API, which is available on Swagger. There's a link on one of the later slides in my presentation to do things like give me back values. So use the H limit here. If I look at code, it should show better. Luminosity H limit, an offset of 0 would show that I'm getting the first 3, 0 to 3 of the limit. So if I send that, you can find out what am I getting back from the luminosity, and it returns data as a series of, in this case, actually strings rather than integers. It says at a type of integer. This is because it's Comet is trying to force stuff into a MongoDB database, which is not entirely set up to take time series data. And you can see that there is a key, which is the time received, which is actually when the subscription has run. If you go back to looking at the subscription itself, we are only passing in a value. We're not passing in any time information. So this is actually not the information that the when the luminosity was created, not the information which was put in the IoT agent. It is actually the time that the subscription was run. We can similarly do various other things like sum values or various aggregates. So here we're looking at an aggregation of summing up all of the motion sensor elements over a period of 1 minute. So once again, if I send that, it's saying over 1 minute we've had the 10th, 11th, and so forth of the samples. We had 2 samples there, 14 samples there, 20 samples there. So what we have here is an ability to say what has happened over a minute, or what has happened over a day, or whatever. If we then go back to the tutorial, you can actually then look at my device history. My device history is now showing stuff on a graph, and this is the whole point of doing this time series information. You want to have buckets of things. So I was saying, okay, at 8 o'clock on the nose, I was just doing 1 motion sensor event, and then we go on to 3 motion sensor events. If you notice the time up on the top of my screen, you'll notice that it's 10 o'clock here in Germany, but it's actually 8 o'clock Universal Time, which is where my Docker container is running from. So the timing is correct. Now, you can get hold of this information in various different ways. You can see you've got a sum, which is how many times the motion sensor was fired, or you've got minimum and maxima. But the point here is that you need to be able to retrieve the data back out of Comet in order to get the information in there. Comet is doing all the work, so it's actually moderately overloaded. I'll get back to more details about how you actually can display this stuff on screen later on in the presentation. But I'll move on to the next slide. Okay, so that was the way that it gets hold of information. As I said, we're overloading Comet here slightly because it is actually doing a lot of work. If I now go back and add in Cygnus into my system, we then end up with 2 different components doing 2 different jobs. Because MongoDB itself is not a time series database, it means that if we just had Cygnus on here, sorry, just had STH-Comet on here, it is listening, it's doing all that pushing into the database, it's also doing the retrieval from the database, and then it's also doing the bucket management. And the bucket management can take some time. Now, this is therefore not a scalable solution. There's this improved scaling if you delegate the data persistence to, hey, a data persistence component like Cygnus. So Cygnus is able to push, as we saw in a previous webinar, is able to push data to MongoDB database. Comet is able to read from that MongoDB database, and it is able to therefore obscure the details of where the data persistence is going in order to offer a standard interface. So you don't really care whether it's a MongoDB database or some other database. It's those details don't worry you. So if we're going to do it using Cygnus, the setup is very, very similar to the way we would do it using Comet itself. Once again, we can see, is Cygnus available? And yes, I'm on the latest version 1.18.3, which supports the NGSI v2 interface. The latest 1.18 does. So we are now able to aggregate the same information using a standard subscription, v2 subscription, and it's going to, the notification is to Cygnus 5051, which is the standard port for MongoDB output. And I don't need that legacy flag anymore. If I just send that, I'll do the other one as well, which is just sending the lamp luminosity. Now, obviously, each time I restart the system, I lose all my history. So I now need to start my devices again. And assuming we actually have a subscription that is working, yes, we've got a motion sensor, and it's got a success code, it's done some stuff, it's pushing stuff to Cygnus, and we can once again go to that short-term history graph and see what's going on at store 1. And you can see, yeah, it's had different amounts of stuff coming through. Okay, move back to. So, still not dealing with the actual graph stuff. It is actually there's another alternative for how we get the information out of these things. This is how Cygnus does it. It's 5051. Once again, it's just passing an attribute, and it's v2 rather than v1. Yeah. So the other alternative for pushing data into a system is called Quantum Leap. Now, Quantum Leap uses either a specific time series database like CreateDB, or it uses an add-on for Postgres, which also does time series. So Quantum Leap itself is not responsible for doing the all the aggregation type commands. So it means that it doesn't get as easily overloaded as Comet would do. So if we to use Cygnus, it's very similar to the previous example. I'll just briefly show you on screen again, which is where if we go in here. Now, another addition, nice addition, which Cygnus is able, not Cygnus, Quantum Leap is able to offer, is that because it is pushing to a time series capable database, natively time series capable database, it links very nicely with other third-party tools. This is another way you can get your display up, get your wiggly line graph showing what's actually happening, and seeing that you can get stuff on screen so you can react as necessary. If we look at the Docker Compose for Quantum Leap, once again, it's very similar. It's very simple. It just consists of an open port, which is then listening into the subscriptions. This is because NGSI v2 does not actually start off with the ability to do any time data itself. So it needs to wait for this push to actually say, oi, this is where the data is coming in, this is where the data is coming in, and then it will use that time to get hold of the various information. So Quantum Leap has actually got a few more other, a few additional pieces of useful information in it. With our subscription, you'll notice that you actually also need to pass in metadata. So obviously, when I'm updating my motion sensor, I have metadata associated to my count attribute. In other words, it is saying, when was this attribute last updated, modified? And therefore, it is not the rate of the subscription that is the time the subscription comes in that is used for aggregation. It is actually the time which the context data was last updated. So obviously that is more accurate. Apart from that, it's very similar. It's a standard notification. It goes to the port, which is open v2 notify. On top of this, another quirk that Quantum Leap is able to offer, another functionality, is it is able to offer a geofencing functionality, you can find out what was happening with the devices which were currently in that area at that time. And this is done by obviously passing in a location, as you would expect. So you can see where I've changed the subscription so that I've got both the value I'm after, the luminosity, and the location as well, and this metadata. So it's got more information coming in. It's able to get hold of more information coming out. And if we check to see what's happening, I just need to go back into 300,000 again. Okay, we've got some data coming through. And you can see information is coming out as you would expect. So this means that there are a series of additional things you can do here. For example, you can find out what was the minimum value over a time period by doing a very similar parameters to STH-Comet. Again, there's a Swagger file. It's in one of my slides later on. So you can see what's going on. So what's happening the last 3 minutes. You can find out that the last 3 minutes were these values here, and we've got okay, I've only been running 2 minutes. The first value was null, and then the lowest values are 1600 and 1900. Or you could, of course, add in geofencing, and geofencing is just purely done using the standard parameters you would use in a context broker. You would use a geometry and a coordinates to find out what is, in this case, georel near, which is within 5 kilometers of the point XYZ. I don't know if these values are actually in there or not. I can't remember if they're in that location. It might give us no values, but once again, it's just going to narrow your data down. And you can see, okay, we've got these are the values coming through. Each return value is going to give us an array of 2 parts, which is obviously the time element and the values element. Okay, so we can get data in and out of a database, but what else do we need to do? Well, we need to get something coming up to actually see what's going on in a graph. And just saying how Quantum Leap can get hold of the information briefly. Those are the various Swagger endpoints which are necessary. To get hold of the stuff in the graph, you have multiple ways you can do this. I mean, FIWARE does not force you to go down any one particular direction. Now, the thing you saw on screen earlier is build your own. An advantage of doing a build your own, of course, is that you are using the interfaces which already exist in Quantum Leap or Comet to get hold of the information. So you are abstracting out what the actual database is. I don't care what the database is. I don't care whether it's Postgres or it's MySQL or whatever, or MongoDB. I just use whatever. And of course, there are plenty of charting libraries available. I believe the one which my example uses is Chart.js, but you can also use high charts, e-charts, whatever. And all that needs to be done is you need to look at the retrieve the data, manipulate it as necessary. As I said, it was an array, and I can get hold of the code to do so. Code to do this is in the is really, really simple. All I need to do is as follows. If you take Quantum Leap as an example, I'm actually using the direct SQL interface here, which is one way you can do things. If you're doing a more complex aggregation, you might want to do this. If you look at the Comet example, I'm actually using the Comet Swagger interface in order to get hold of the aggregation minute. I showed you this example on the Postman a moment ago. This one is just doing, okay, give me 1 minute time series and run a SQL statement. So all we need to do is we do whatever we're doing for the statement to get the data out. We put it place it within a promise, because obviously if I'm using Node.js, I need to make sure that that has completed before I move on to the next step. And I then need to massage the data as necessary. This is how I'm taking the data from what the information that Comet is giving me, which is an array of context element attributes, and pushing it into the format that the Charts.js wants, which is a data, a labels, and a color. You can see the value I'm taking here. I have to do value of for the Comet data because it's all string values. Whereas if I look at the time series data, I can just push the element itself, because Quantum Leap is able to receive number data and actually get hold of it as you'd expect. And then, having done this, I get an array of data. Okay, how can I display that on screen? Well, I can display that on screen by going to my front end and writing a little bit of JavaScript. This is just saying, okay, my data, the sum, the max, the min, is just a lump of JSON. So let's JSON stringify the value which we have received from the back end. And then this is just a simple example direct from Chart.js to say, I have a bar chart, it has the following labels, it has the following options, x-axis, y-axis, begin at 0, and what have you. And you can see I am loading a value direct from a CDN. So that's how you would do this in a custom fashion. This might be too much work for you. You might be better off using an existing component such as Grafana. As I say, Grafana is capable of connecting to Quantum Leap. So it should be the case that I've got a Grafana component running and listening here. It's just a default admin because I've just started it up. Don't need to change the password. And here you need to be able to get hold of the information to add a data source. The full details of how to get hold of a data source are available within the Grafana part of the Quantum Leap tutorial, which I'm getting the details now. Okay, so let's add a data source. It is because it can take either CreateDB or Postgres. It happens to be a Postgres database I've got at the moment, and you can fill in the values. The name is CreateDB, let's say, and the host name is whatever I had in my Docker container. Now the database name is based on the tenancy of the FIWARE service path. So I have OpenIoT as my data, and I have a user called Crate. And we're not using SSL, so we can send that, save and test. Yes, connection is okay. Having done that, we can then go and configure a dashboard. Let's create a new dashboard. We can add a query. We've only got one database. And we can just fill in the values here to go from, say, the lamp. Again, there's a small prefix there. The time column is time index because that is what we placed in from the metadata. That's the time column. That's right. Select values column luminosity, and the metric column is the ID. I think that's right. And you can see here, yeah, you can see my lamps are passing in data on the right-hand side, because this is showing everything I've got for my 4 lamps. You can the column luminosity is varying over time as my lamps are switched on, switched off, and I don't know if I can expand that. Probably that's better. Yeah, you can see it move better, moving up and down there, and you can see what that it's coming through as you would expect. Obviously, if you want to have a more complex query, you could put a more complex query into the system. Now, there are obviously other ways you could do this. You could go through WireCloud. WireCloud has got a Quantum Leap widget, which just means you just wire up the converter. Once again, you could do something using knowledge, but these are all basically the same thing. Once you've got your data into a database, you can abstract it as necessary. Okay, the latest iteration of the NGSI interface, NGSI-LD, linked data, and there is already a temporal interface defined which does a similar job to the time series. Indeed, the temporal interface is likely to be adding in aggregation functions such as Comet and Quantum Leap in the near future. But the NGSI-LD temporal interface, as defined at the moment, is slightly different. It doesn't give you buckets. It says, give me all the values of an entity between time x and time y. And it's effectively an extension of the standard query stuff, which means that instead of doing give me this vehicle, I can do give me this vehicle and give me these attributes, give me speed and brand name. Now, in this particular case, obviously, I'm not rebadging my car, so the brand name has only given me one element in my my response, whereas the speed obviously has been observed at multiple points. Observed at is a standard property of a property. It's the standard metadata element, which is equivalent to the one which you passed in for Quantum Leap. And you can actually, if you want to, observe on additional temporal elements. But you can see what you get here is what are all of the values which took place for this particular element. If you want to find more information, the latest version of the NGSI-LD specification is 1.2.1, although it is being updated and revised. You can see more stuff on screen there afterwards. I'm sure that at a later date I will go into more details as to how to obtain information from a temporal interface, but that's just a quick summary for now. And that, in the summary, is what short-term history is about. It's about discovering trends. It's about getting hold of warnings that things are dropping off a cliff or going up very fast or whatever. It's getting maximum, minimum. You can do sums, averages, you can do sum squares, but it's all about over a period of time, which makes it slightly different to the standard data persistence, which is more to do with logging. There are currently 2 components to deal with short-term history. You can either use a time series specific element like Quantum Leap, or you can go for the simple way of just overloading your MongoDB database and using Comet. It's up to you, depending on what you want to do and depending on how far you want to scale your elements. You can display using multiple graphing tools. Obviously, time series data in a database on its own is absolutely useless. You want to be able to see what's going on, and therefore you need to use a graph. And finally, the NGSI temporal interface is up and coming and is likely to be doing a similar job in the near future. So that is the summary of time series, and I hope you've had a good day, and I will leave you to enjoy the rest of it.